Welcome back to TBS Skylabs, which is just my rooftop. So what we're going to do today is we are going to try and replace some of the components that we used before, like our LED. I've lost my LED, but I do have one somewhere. Like our LED, and we're going to replace that with some other components just to see what effects it might have if we switch around other things with our LED and what things we might need to consider when doing that. Now again, this is maybe a bit of an aside, so if you're doing this as a catch-up, you possibly want to just like jump straight on to the next video, but I think it's quite useful for people who are wanting to maybe play around and build up different systems as well. So, what did we have last time? So we had our power module. Now, as you'll notice, or probably have noticed, I'm really bad for working with power on. That is bad. It's bad, not so much in a system like this, because 5 volts, you're going to be pretty safe. But if we move on to working with robotics, where we need more power to power motors and stuff, then we could get a nasty shock as well. So let's build up good habits now, and not get nasty shocks later. So anyway, I had my resistor connecting from the positive line, or possibly the other way around with the LED. And then I have my LED and the long legs on the positive, and that was connecting back through to the negative. I lost a wire. Aha, here we go. So that one's going to connect through to the negative side of things. It's not a great line. I might need to stab some of these lines a little bit. I think I mentioned before. So I just want to make sure that so when they make them in the factory, sometimes they're a wee bit stiff. So we sometimes just need to make sure that they're going to work for us as well. Okay, so I'm going to replace that wire because it's rubbish. Let's just use this yellow one. Now you can use these bendy wires like this. This is actually probably better for doing quick things. If you're prepared to spend a bit of time, you can use these like more solid to the ground wires that, or to the board wires. They make it a lot more tidy. So it's same, but different. So, turn it on? Yay! I get an LED. So, but then what if I want to change things and add in a buzzer? Okay, so I've got this here, and this is a passive buzzer. Now, I've left my actual buzzers in school. But you'll see on the back here, it basically has, if you ignore that bottom bit, it basically has an in and an out. Not totally sure what this third line is about. Somebody knows, let me know. But down here you can see that we have a positive and a negative side, and a middle side, which I assume is going to be for sending some kind of like signal to control it or something like this, or change the frequency, but I'm not totally sure. So our first thought would be to just take out the LED, plug the positive leg of our buzzer into our system. I'm going to have to move my resistor so that it fits, and I'm going to plug it in there. So that's going into the positive side, and then the negative side is going to come out to the negative. Now if I turn it on, oh, I don't hear anything. How sad. Alright, and perhaps some of you can guess why. It's because a buzzer, at least as far as I know, requires a bit more current to power it than an LED. Okay, so the sound is going to take a bit more energy than the light. So how did I reduce my power before? I reduced my power with my resistor. Or reduced my current, sorry, I should probably say, with my resistor. Apologies to any physics teachers. Feel free to punch me or send angry comments or whatever. Again, I'm taking this from a computer science perspective, which is maybe a bit more practical than you need if you're doing a physics test. So that's my focus. So let's try and plug that in there. There we go. It's going to squish into our board, and then I'm going to connect the negative into here. Now this time when I turn on the power, hopefully you can see that there, I'm not sure. Yeah, you can. Yay! This time we can hear the buzzer because we don't have... Sorry, I'll turn that off so you can hear me. But this time we can hear the buzzer because we don't have the resistor. So if you are having a problem with components, you might want to think about resistance and how it all goes together. That way, ideally you need to sit down and work out the resistance of your different systems. But again, that's we're still kind of just trying to keep this fairly practical and not get too much into the maths and the theory. Alrighty, so that's one possibility. The other possibility, I could use my thingy here, but I'm going to take it out. And instead I'm going to plug in my LED like before. Again, long leg goes to the positive, and the short leg goes to the negative. Now, this time, I'm not going to change the component that's giving me my output, which is the LED. This time, I'm going to change the resistor. Now, some of you might have seen these kind of resistors before. Oops, I don't know if you can see it here. And this is a variable resistor, or I think it's called a potentiometer as well. Please, again, feel free to correct me if I am wrong. I've got some other ones somewhere as well that are just like little blue ones that are even smaller that you kind of adjust and leave in a system. So this is more if you wanted to like allow the user to adjust it, whereas the other ones might be more if you wanted to put it in a system that could be adjusted elsewhere. Anyway, so what this does is by turning this little handle, I am increasing or decreasing the resistor resistance. So it is what we would call a variable resistor. Now, let's unplug. Now, I'm going to connect. This has 3 legs. Why? Who knows? So, one leg's going to connect to our positive, one leg's going to connect to our negative. Stab in there. It's a bit tricky to get on the board at times. You can do. Sometimes it helps to kind of curve the back teeth in and then move it around a bit. Again, moving teeth is not going to cause any big issues on the whole. However, you want your components to last long, so you don't want to be too bendy with them, but you do need to bend them to get them into place. Now I'm going to go from there, I hope, squish, into the negative line of my breadboard over here. Oh, sorry, positive. Yay, into the negative of the breadboard. Okay, so I have the power basically flowing from one side to the other. Now, on the other end, I am going to connect my LED. Now, the assumption is that the power is flowing here or coming out here, but then depending on where I've adjusted this to, it's going to allow some power or some current to flow out this side and onto here. Now, at the moment, it's not going to work. Can you guess why? Because our LED is not quite yet connecting to the ground. Okay, so we're going to have 2 grounds in this system, and it's basically just to let the electricity flow where we want it to, whether it's this path, or this path, depending on the resistance of the system. So let's turn it on. Oh, I have a bulb. Now, oh, it's quite bright. So now, in theory, if I adjust this, oh, it's getting brighter, or getting less, or getting more. And this is how like a dimmer switch in your house maybe works, is by changing the resistance, we're going to get different amounts of current flowing into our LED, or flowing down the other way and escaping. Okay, and this is a variable resistor slash potentiometer. Okay, so just wanted to give you a quick look at how we could replace, like say the LED with a speaker, or we could replace our resistor with a variable resistor. One other thing to think about is I'm using 220s. So if I increase the size of that, what do you think would happen to the LED in our basic system if I was to just go back to what we had before? So instead of using a variable resistor, what if I just used so I'm using a 220 now. What would happen if I made that resistance bigger? And what would happen if I made that resistor smaller? Have a think. Alrighty, ciao.